Hey folks, in my ongoing acquisition of old recording gear, I have started to dip my toes into the pool of analog tape. This is my Tascam Model 32 reel-to-reel recorder. It's a quarter-inch 2-track reel-to-reel that I hopefully plan on using as a mastering deck in conjunction with my Tascam MS-16 up in the studio. However, I bought this as a broken and for parts eBay listing. The previous owner had sold it once in eBay listing, but the shipper had dropped it and destroyed the main control board in the process. At first, the pictures I got led me to believe that a single IC needed to be replaced, but it also had some broken traces. The symptom was that it would fast forward on power up and couldn't take any other controls. I used some tape to make flags to indicate rotation to help confirm this was the case, which is an old trick I learned from building and working on drones for a living. Now, upon removal of the rear cover, it was clear that a lot more of the board's traces were cracked, as was the rest of the board itself. Now, depending on the situation, fixing traces can be done easily, but first the board needed to come out so that I could get a good look at it and make sure that I handled it properly. Most every connector on the board itself is unique and or color coded, with only a handful of wires needing to be desoldered. The best tool here is to take pictures. I also marked the solenoid wires with a Sharpie left to right with 1 through 4 marks indicating their order going into the board. Everything else just came right off, and you can see a handful of the connectors just hanging loose, and because they are unique, a different amount of pins, different colors, they would go back in the same place relatively easily. With the board on my messy workbench, I began using a technique I've used for years. The first step is to peel back the solder mask, which is that green film on top of the copper PCB trace. This will allow solder to stick to the trace at the point of the break. With that done, I now bring in my soldering iron to tin both sides of the break. Sometimes you can get away with just bridging the solder across the gaps, like if you're not dealing with like a breakage in the board, but like the trace itself comes delaminated and gets cut, something like that. You could probably solder it back together. For this one, you need to add some rigidity because the board itself was snapped, and so sometimes some wire, some thick wire, or I like to use pin headers to give it a bit of extra rigidity. Just make sure that you don't bridge traces that are next to each other. Now, at first this seemed to fix the problem, but if, like me, you know a lot more now about how reel-to-reels work compared to when I shot this footage, you'll notice a key problem. There is no tape on the reels. See, there are tension arms that keep both sides of the tape at tension, and they also relay to the electronics that tape is present. The purpose of this is to indicate to the control electronics to stop the motor spinning once the tape has completely unspooled. For testing, I would later just use tape to hold this arm up to simulate tape being on the deck until I got some actual reels of tape. I thought I was victorious here, but as the night went on, other problems would pop up and the unit would vary in its functionality. You could hear clicking, edit mode had no effect on the response from the control panel as it should, fast forward problem would come back, and sometimes it would just do nothing at all. Over the course of the repair, I would take other looks at the board, probing it with my meter, and keep finding more breaks in the PCB and its traces. There are a lot of ICs on the PCB, and while this is an analog deck, most of these ICs are digital TTL chips. TTL, or transistor-transistor logic, relies on inputs that are either on or off to produce outputs that are also either on or off, which is really the basis of all digital electronics. The play button is an input signal that is either on or off. The solenoids are either deployed or they are not, etc., etc. And so all these chips need very clear input signals. Either they're going to read a logical 0 or a logical 1. However, when you have broken traces or nearly broken traces, I imagine you could start getting floating signals, weak signals, or signals that otherwise confuse the logic. Now, I haven't completely analyzed this circuit. It's a rather large schematic, but it's my opinion that the problem is that there was a broken trace that put the chips in an inconsistent state. A certain combination of buttons would put the logic in a state that it did not understand. And the evidence to support this theory was that after the machine was powered down and left to sit for a while, the machine could be powered back on and it would work again. Could even make a short recording on it, but eventually found itself in a state where it would not respond to any input. And so the answer, what actually fixed it? Well, I actually just bought a replacement board and installed it. I'm sorry if you expected something more here, but there's a lesson to be learned. When I was doing my research, I saw Tascam Model 32s going for about twice what I paid for the unit. The seller originally sold this exact unit for $650, and I paid $350 for it shipped. Now, fixing the unit would have been free if I could have fixed all the solder traces, and maybe one day I will fix that board. However, a replacement board cost me only $100, and in the end I was still in this for a couple $100 less than the guy that bought it before me. Installing the main board was easy now that I had taken the first board in and out once. Since the procedure to put this thing back together is decently involved, I tested it before any of the outer shell went back on, and everything seemed fine. I went ahead and installed all the other outer shell components, and with it together, I tested it again, and everything is working now. Sometimes you can fix things your own way. Sometimes it's easier to take the easy, more expensive path. It wasn't until I saw the total cost of the broken unit and the board that I realized that buying the board was the easy, right choice. Time is money, and I spent hours and hours trying to fix that board. But why? At such a point that you begin to put a dollar amount on your time, even if it's the hourly wage you make at your job, when you start looking at things this way, I easily spent more than $100 worth of my time trying to fix that junk board. Some of that was, to pique my own curiosity, and I learned something in doing that. But now that board just sits in my parts pile, and one day maybe I'd like to learn exactly what's wrong with it and fix it. But for now, I'm just glad to have a working mastering deck. Thanks for watching this video, folks. I like fixing things, I like recording things, I like doing a lot of different things. If this is something you enjoyed watching, or you enjoy these things as well, maybe consider subscribing. My YouTube is my catch-all video dumping spot, whether it's videos like these, unboxing videos, in-car footage from my rallies, or re-uploads from my Twitch channel. It all ends up here. So maybe I've got something here that you do like. Anyway, thanks again for watching, and hopefully we'll see you next time.